I'll be stating out the four equations of motion we are going to be deriving. The first one is V equals U plus AT. The second one is S equals UT plus half AT square. The third one is the square of your V equals U square plus 2AS. The fourth one is your X equals U plus V over 2 all multiplied by T. Those are your four equations of motion. That's the first one, the second, the third, and the fourth. We are going to be listing out the parameters we used. U is our initial velocity. It is measured in meter per second. V is our final velocity. It is also measured in meters per second. S represents distance, which is measured in meters. A represents acceleration, which is measured in meters per second square. T represents time, which is measured in seconds. Let's get to the nitty-gritty of the day, which is the derivation of the four equations of motion. Before we do that, let's understand how we can represent the term change in velocity. Change in velocity can be represented as that it is also the same thing as saying your final velocity subtract your initial velocity. In other words, instead of writing final velocity, we can simply write it out as V minus U. That's our change in velocity. The next thing we have to understand before we do anything is what our acceleration means. Acceleration is the rate of change in velocity, meaning anything that has to do with rate, you are considering time. So our rate of change in velocity would be A, which is also equal to change in V over T. We are putting our T there because of the term rate. And you know change in V is the same as V minus U. So our A technically would be equal to V minus U over T. When we cross multiply, A will multiply T to become AT on the left hand side, while V minus U would be on the right hand side. If we are to make V the subject of the formula, our V would definitely be equal to U plus AT. And that is the first equation of motion. For the second equation of motion, we are going to be introducing the term average speed. Coincidentally, average speed is also how we come about our equation 4. But let's stick with equation 1 for now. Average speed is the same thing as your distance over time. But the term average speed is also our mean speed. And you know, mean is the addition of the data given divided by the number of data. So if average speed is distance over time, average speed is also our mean speed. And if a body is moving, it has two speeds, the initial and the final speed. So the mean speed will be the addition of the two speed divided by the number of speeds. That's U plus V over 2. If average speed is distance over time and average speed is also U plus V over 2, instead of writing distance again, I'll just go ahead and write S over T, because S is representing distance, and S over T should be equal to U plus V over 2 since both of them are average speed. With this, now I'll go back to equation 1. and check. V is u plus at. So anywhere I see v, I'll put u plus at, meaning my s over t would be equal to u plus, instead of writing v, I'll write out that, which is u plus at all over what? 2 now. Now our s over t should be equal to 2u plus at over 2. Now we can separate this. We can just say s over t is equal to 2u over 2 plus at over 2. Because if we add those two fractions, we are still going to get 2u plus at over 2. Now our 2 will cancel out that, and we will be left with s over t equals u plus at over 2, or half at. To make s stand alone, we can cross multiply, meaning our s will multiply, our t will multiply everything on the right hand side. So to cross multiply, our x will become t multiplied by u, that should be ut, and when t multiplies half at, it will become half at square. So generally our s should be equal to ut plus half at square, and that will be our equation 2. For our equation 3, we'll have to revisit equation 1. So for equation 3, we are going to square equation 1. If you notice, our equation 1 is v equals u plus at. So we are going to square equation 1, meaning we are squaring the left hand side and also the right hand side. So that's our equation 1. V is equals to u plus at. So I'll square the left hand side, and I'll also square the right hand side. So on squaring the left hand side, it comes out exactly as it is, which is our v square. But on squaring the right hand side, we are going to have two brackets. That is v equals u plus at multiplied by another v equals u plus at. And if you expand that bracket, you should get u squared plus 2uat plus a squared t squared. The next thing we are going to do would be to factorize out 2a. So our left hand side will remain the same. On the right hand side, we are going to factorize out 2a. So our v square would be equal to u square plus, now we are bringing out 2a from the remaining two expressions. When we bring out 2a there, what will be left there would be ut. Now a is already out, so that's ut. A is already out, so we'll be left with just one a there, since a is already out. So a and t square, but there's no 2. Since there is no 2, we have to put a division sign. Since there's no 2, put a division sign and put 2. Now if I expand this, I'm going to get back 2uat plus a squared t squared. But if you look at what is in the bracket critically, you would see that this bracket is the same thing as equation 2. So look at that bracket critically. Ut plus at squared over 2, or half at squared, is the same thing as equation 2. So after writing my 2a, instead of putting the bracket, I can go to equation 2 and just write everything there as s, because s is equals to ut plus half at squared. So that's my equation 3. For my equation 4, I'll be going back to equation, that's the beginning of equation 2. As I said, coincidentally, average speed is how we generate both equation 2 and equation 4. So from that, let's call that equation x. So from equation x, if I'm to make S the subject of the formula, it will just straightforwardly become, so from equation X, if I'm to make X the subject of the formula, it will just become U plus V over 2 all multiplied by T. So that will be U plus V over 2 all multiplied by T. And that will be my equation 4. So those are the 4 equations: equation 1, equation 2, that's my equation 3, and that's equation 3, and this is my equation 4. So those are the 4 equations of motion. So for any linear motion, one of these equations should be enough to solve it correctly and completely. Thank you.